All right, let's take a look at our first problem. We are going to construct a truth table for this statement. So we need to go ahead and sketch out our truth table. Now the first thing we can do is declare the individual letters, our sort of fundamental statements. And we have a P, we have a Q, we have an R. Now from this point forward, we can construct one thing at a time, only using pieces we've already constructed. So if we only have P, Q, and R, we cannot yet construct that first bit, P implies not Q. First, we're going to need to build up not Q. But once we have not Q, we can construct P implies not Q. Okay, we can also go ahead and make Q implies R. Once we declare not R on its own, we can also construct not R and P. Once we have both Q implies R and not R and P, we can make the disjunction of Q implies R or not R and P. Finally, once we have that constructed, we can go ahead and make P implies not Q and exactly what we just made, Q implies R or not R and P. Okay, so now we just need to know how many rows we have. Since we have 3 letters, we need 2 cubed rows. So we can have true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, and finally false, false, false. Now we'll just go row by row. In the first row, since Q is true, not Q is false. Since we have P, the hypothesis is true, and not Q, the conclusion is false, that's the only scenario in which this conditional statement would be false. Since we have Q, the hypothesis, true, we have R, the conclusion, true, that makes a true conditional statement. R was true, so not R is false. Since not R is false, here we have this side of the AND statement being false, so we don't even have to check the other one. If either one of them is false, the AND is false. Now let's look at this OR. Q implies R, that was true. If any side of the OR statement is true, then the OR statement is true. So we'll go ahead and mark that as true. And then finally, since P implies not Q is false, then this AND is also going to be false. So there's our first row. In the second row, P is true, Q is true, R is false. Since Q is true, not Q is going to be false again. P is still true, and not Q is false, so this conditional statement is false. Q implies R. Well, now we've got Q is true, R is false, so this conditional statement is now false. Not R has become true. Now we have not R is true, and P is also true. So in this row, the statement not R and P is true. Since the right side of this OR statement is true, this OR statement is still true. And now that we have the right side here, this OR is true. We look at this AND, but P and not Q, still false. So since this statement is false and it's the left side of this AND, still false. Okay, we're going to start going a little bit quicker through this. For example, I'm just going to go ahead and fill out not Q all at once. So since Q is false, not Q is true, but when Q is true, not Q is false. We're just switching the value of Q. Similarly, over here in R, we just switch the value of R. Okay, now here, When you have a conditional statement, the only time a conditional statement is ever false is when the hypothesis is true and the conclusion is false. So are there any lines where P is true and not Q is false? Well, the only time that lines up is here, true, false, and here, true, false. Otherwise, we have true, true, or we have a false hypothesis. So in every other row, this statement is going to be true. We can do a similar thing here with Q implies R. We're going to look for any rows where Q is true, R is false. Q is true, R is false. Here, that's already marked as false. And here, Q is true, R is false. So in this spot, the conditional statement is also going to be false. Otherwise, either Q was true and R was true, or Q was false. So every other row, this is true. Now let's look at this conjunction. Here's P all the way at the left. Here's not R, and we're just looking for where both of them are true. So for example, anytime not R is false, I automatically know that this conjunction is going to be false. Where not R was true, I can now check what about P. In this row, P is true, so the and will be true. But in these two rows, P is false, so here I'm going to put falses. Here now we have an or between this statement, Q implies R, and this statement, not R and P. So if either one of these is true, I'm going to put a true. Only in this line are they both false. So this is the only line where this disjunction is false. Otherwise, at least one of those two sides was true. Now we've got a conjunction. One side is this column, and the other one is this one over here. So we need both sides to be true, but notice that this one is only excluded here. So because this statement is false in this row, this conjunction is also false. Otherwise, this statement is true, so I just need to go back and check what about P implies not Q. If this is false, then overall this conjunction is false, but notice everywhere else this was true. So both sides true, 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 true. So there we have it. We have the truth table for the given statement. Moving on. Construct a truth table for this somewhat shorter statement. All right, let's just go ahead and throw down a nice large table. We're going to go ahead and start with our P, Q, and R. We're going to need a not Q and a not R. We're going to need to build a conditional statement, a conjunction, and then we should be good. So we need our P, Q, R. We're going to need a not Q. We're going to need a not R. Then we can build P implies not Q. We can also make Q and not R. And then we can go ahead and stick those together. P implies not Q, or Q and not R. So we can do true, 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 false, etc., etc. This is always the most exciting part. Throw down these four falses. True, true, false, false, true, false, true, false. Great. Now I just need to look at Q. Q alternated true, true, false, false, true, true, false, false. So I'm just going to reverse that here. So we get false, false, true, true, false, false, true, true. Not R was alternating every row, so I just do the same thing, but I start opposite. So false, true, false, true, false, true, false, true. Now I'm just looking between P, not Q. The only time a conditional statement will be false if I have true pointing to false. So here, the arrow is going to be false. Here, the arrow is going to be false. Otherwise, I have true pointing to true or false pointing to anything. So the first two rows, this evaluated as false. Otherwise, it was true the rest of the time. Next, we're going to do a conjunction of Q with not R. So this and this column, and I'm looking, are they both true? So no, yes, no, 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 yes, no, no. So overall, we've got false, true, false, 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 true, false, false. Now I've got a disjunction, an or statement, just between these two, which are next to each other. So if either one of them is true, I get a true, otherwise I get a false. So the only row in which we get a false is the first one, otherwise at least one of the two was true. Okay, another truth table construction. So we go ahead and we throw down our individual letters. We have a P, we have a Q, we have an R. The only thing we need to negate is the not R. We're going to go ahead and make a Q or R, then P implies Q or R, and then we can make our whole thing. P implies Q or R, and not R. Okay, now as always, we just need to make all of our rows. Let's just go row by row now. True, true, true. Well, since R was true, this is false. P and Q are both true, so this is true. The conjunction Q or R is true. If the conclusion is true, the conditional statement is true. And now, since the not R was false, this is going to be false. Next, true, true, false. That means not R is true. This conjunction still true. Now we still have a true conclusion, so this is still true. And now looking at the conjunction, we've got this large statement immediately to the left. That's true. And the not R also true. Okay. Next, true, false, true. So we switch it and get not R is false. Q was false, but R is true. So this disjunction is true. The conclusion is true, makes the conditional statement true. But looking here, since not R is false, this conjunction false. Next, true, true, false, false. So not R is true. Q and R were both false, so this is now false. Now I have a true hypothesis with a false conclusion, so this arrow fails. Since this arrow fails, the conjunction automatically fails. False, true, true. I switch R to get a false here. Q is true, so the conjunction is true. The conclusion is true, so the conditional statement is true. Not R, however, was false, so this conjunction false. False, true, false. Switch this to true. Q is true, so this disjunction is true. The conclusion is true, so the conditional statement is true. And now both sides are true, so this is true. Moving on. False, false, true. Switch this to false. R is true, so this disjunction is true. Conclusion is true, so the conditional statement is true. However, not R is false, so this conjunction is false. And lastly, false, false, false. Not R becomes true. Q, R were both false, so this is now false. In this conditional statement, the hypothesis P is false, so it is vacuously true. And now not R is true, and this conditional statement was true, so the conjunction true. Another truth table construction, so we go ahead and we throw down. We're going to need our P, Q, P implies Q, Q implies P, and then we can conjoin them. P implies Q and Q implies P. Okay, since there's only two individual letter statements here, we only need 4 rows. True, 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 false, false, true, false, false. Conditional statements only fail when the hypothesis is true and the conclusion is false. So here, hypothesis true, conclusion false. This will be the only row in which we get a false here. Looking at our other conditional statement, hypothesis Q is true, conclusion P is false, that's here. Q is true, P is false, so that's the only row where this will be false. Otherwise, conditional statements are evaluating as true. And now I'm just looking at this and, where are they both true? Top and bottom. So true, false, false, True. So this statement here, P implies Q and Q implies P, is actually pretty important. We're going to refer to it later on. Notice that it's true when P and Q are both true, or also when they are both false. This statement in essence checks, are P and Q the same? If they're both true, we get a true. If they're both false, we get a true. However, when they are different from one another, this statement evaluates as false. So this compound statement, P implies Q and Q implies P, in essence is a statement that asks, are they the same? All right, next up, we want to show that a statement is a tautology. So we're going to construct a truth table and see that it is always true. So we need a P, we need a Q, we need an R, we need a not Q, we need a not R, then we can make this not Q and not R. Then we can make the conditional statement, P implies not Q and not R. Then we can take that, P implies not Q and not R, and we can conjoin it with Q. Then we can take all of that, P implies not Q and not R, and Q, and we can make it the hypothesis of a conditional statement with not P as the conclusion. We don't actually have a column for not P yet, so I'm just going to go ahead and squeeze it in back here. Okay, so I couldn't make this statement until not P already existed as a column, and it didn't yet. However, if I put it here, that's fine. It only depends on P. Okay, so go ahead and throw down these vertical dividers for a little clarity. This is going to be a large and crowded truth table. But if we just go through one step at a time, shouldn't be so bad. True, 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 false, true, false, true, true, false, false. Okay, we had 4 trues for P, 4 falses now. Q is alternating every other line, and R is alternating every line. P was going every 4 lines, and now it gets reversed, so I have 4 falses followed by 4 trues. Q was every other line, so I have false, false, true, true, false, false, true, true. R was alternating every line. I just need to make sure I start opposite the way it did before and just alternate every step. Okay, now we can start making our compound statements. I just need to look at the previous 2 columns. It's nice to try to arrange your statements to depend on things close by so that you don't get too lost. And I'm looking, are they both true? Nope, 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 yep, nope, 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 yep. Okay, anytime this was true, it's going to be the conclusion of a conditional statement. So in these 2 rows, the conditional statement is true. If the hypothesis is false, the conditional statement is vacuously true. So in the last 4 rows, since P is false, this conditional statement is vacuously true. Whenever the conclusion is true, the conditional statement is also true. And in this column, we see that the conclusion is true. Otherwise, the conclusion is true, false, sorry, and the hypothesis true. So if the hypothesis is true, the conclusion is false, the conditional statement will evaluate as false in these 3 rows. Now we just need to go ahead and take this, and we're going to do a conjunction, this and Q. Well, in these 3 rows, since this was false, a conjunction with anything is automatically going to be false. Otherwise, in the bottom 5 rows, this was true. So I only need to come and check Q. Looking at Q, it's the one that alternated every other step. So here Q is false, so this is going to be false. And then since Q was true, true, false, false, and we were really only checking Q at this point, it's going to do the same thing. Now, this is the hypothesis of this conditional statement, and anywhere the hypothesis is false, the conditional statement is vacuously true. So 6 out of 8 rows, we get vacuous truth for this conditional statement. Now here the hypothesis is true, so let's go ahead and check the conclusion. In these two rows, not P is true. So the hypothesis is true, but the conclusion is also true. Therefore, this conditional statement is true, and lo and behold, in every row, a true statement, therefore a tautology. All right, another tautology construction. So this one doesn't have as many pieces to it. We just need P, Q. Then we can make P implies Q. We can then conjoin that conditional statement to P. Then we can take that whole thing, P implies Q and P, make it the hypothesis with the conclusion Q. We only have 2 letters going on here, so we only need 4 rows. True, 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 false, false, true, false, false. This conditional statement of P implies Q can only fail here, where the hypothesis is true and the conclusion is false. Otherwise, if they're both true, you get a true. And if the hypothesis is false, you get vacuous truth. Now we're doing a conjunction, so we automatically fail here, because the left side, P implies Q, is false. But where P is false, this also fails. Here, however, P implies Q, P were both true. Now we have vacuous truth for this conditional statement in 3 rows. Because this hypothesis was false, this conditional statement becomes true. In this row, the hypothesis is true, but the conclusion is also true. Therefore, we get another true and another tautology. This statement is always true, no matter what. All right, now for logical equivalence. This will depend a bit from course to course what's considered an acceptable way to establish logical equivalence. Okay, for me, the way I run things, we're going to do it the following way. Okay, we definitely need P, Q, then we can make P and Q, then we can negate that. Okay, we can also make a not P, a not Q, and do this disjunction. Then we can make this statement, not P and Q, if and only if, not P or not Q. Now this statement, if and only if, was the statement we did in an earlier problem. It is simply the conjunction of left implies right and right implies left, which, as we said, just checks, are the 2 statements the same? Are they both true or are they both false? Logical equivalence just means that this statement is a tautology. All right, so let's go ahead and construct this. We need 4 rows, true, true. Okay, I forgot my columns here. I don't actually draw the row divisions, but I do find the column divisions pretty helpful. Okay, of course, if you have ruled paper, it's not so necessary. All right, true, true, so this is true. Otherwise, one of them being false will make this conjunction false, but then I negate it, and we get that. Next, we just reverse P, and we reverse Q. But we're doing a disjunction, so this is the only time that both of them were false. Otherwise, one of them was true. And now what we do, this statement asks, are the 2 the same? Yes, they're both false. Yes, they're both true. Yes, they're both true. Yes, they're both true. So I come back and I say, you know what? In every row, they were both the same. So this statement here, this biconditional arrow, is a tautology. That means the 2 statements are logically equivalent. Some instructors will be fine if you simply point to these 2 columns and point out that they're always the same. I do like to do this one extra step of constructing the biconditional and showing that it's a tautology quite explicitly. Okay, as our final problem, we have another logical equivalence. Here we do have 3 letters to work with, so we're going to need a somewhat larger truth table. Okay, we need P, Q, R. On the left, we need to build up Q and R, and then we can do this disjunction. On the other one, we'll need P or Q, we'll need P or R, but then we can make the conjunction, P or Q and P or R. And finally, we can do the biconditional of P or Q and R if and only if P or Q and P or R. All right, column divisions. This is going to be an 8-row table, so make them nice and long. And remember, our goal is just to show that this biconditional arrow at the end is a tautology, in other words, always true. So true, true, true. Let's just go ahead and do it this way. 4 trues, 4 falses. 2, 2, 2, 2. And this one's going to alternate every time. Now there are no true, false, true, false, true, false, true, false. There are no negations in this exercise, so we just get right to this conjunction. Are Q and R both true is what we're asking. Yes, no, 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 yes, no, no, no. Next we have a disjunction. Is either P or Q and R true? Well, in the 2 rows where Q and R is true, definitely. Otherwise, the first 4 rows, P is true. But in the last 4, P was false, and in these last 3, so is the statement Q and R. Okay, next, just looking back at P, Q individually, we're going to do the disjunction. Is either one of them true? Yes, 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 because P was. Yes, yes, because Q is, but in the last 2 rows, no, they were both false. What about P or R? Well, again, in the first 4 rows, P is true. Then remember, R was alternating, so in these 2 rows, R was true, but in these rows, P, R, both false. Okay, finally, sorry, not finally, second to last, we're going to take the 2 things we just made, P or Q, P or R, and we're going to do a conjunction and look for, are they both true? So in the first 4 rows, yes. In the 5th row, yes. However, in the last 3 rows, one or both of them false. Now finally, I take this big statement that we just made and this previous large statement that we made earlier, and we do this biconditional arrow, which simply asks, are they the same? True, true, they're the same. 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 False, 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 but they were still the same as one another. So we see in every row this biconditional arrow evaluates as true. The biconditional arrow being a tautology is the definition of the statements being logically equivalent.